Hi everyone, I hope my screen is visible. You see, first of all, I would like to give shout out to this tiny guy present in here. So this is a basic project Gemini has cooked for me. So if you see, like if I close the pip mode and remain silent, so something of that sort, like that's me. Though I don't want to show myself, so this is a small setting that I did. It just takes my camera and mic input, and I can use this as something to show you instead of my face, instead of these things. So like I'll just keep it right here, and instead of paint, now I started using Excalibur whiteboard. This is very easy to use. Now let's go back. So now I want to do the assignments of that was given to me in DSA. Uh, so this is our last status. Like in the last live, we tried to do these two problems. I was able to solve this, but yeah, I'm not satisfied with that. So I have marked revisit as yes, whereas the other problem I couldn't solve at all. uh, I have marked it as unsolved, and yeah, I need to revisit this also. um, just a second. Sorry for that. Yeah, coming back now let's do some assignments. So at 100x school, like we get assignments like this in Codeforces, especially for DSA. So let's we had a class for functions recently, which is 2 days ago on Friday, on Thursday, my bad. So let's go ahead solve this. So, and again, the classes are pretty basic as of now, but the whole goal for 6 months is quite good. Right now, it's cool. Let's just focus on this. The first one is hello functions. You're given an integer and write a function that takes n as parameter and prints I'm learning functions exactly n times. So this is a classic for loop, right? So let's get to here. So what we'll do is like we'll just take input. um, I'll use C++ or int n, and C in n. uh, oh my god, one second. Yeah. So this is a basic for loop. So for int I equal to 1, I less than equal to n, I plus plus, if what's inside the for loop, it's just C out. What do you want to print? And we start at 1 and go till n because that's how many times we want. So if n equal to 3, we want this loop to run 3 times, right? uh, so here we'll write whatever we want to print here. I'm learning functions. I am learning functions. So this is what we need to write. Let me just clear this and start with the code. Ah, yeah, now that's clear. Let me do this. Hello functions. It's very important for someone who is practicing to maintain a sheet like this. I'll share a copy of this sheet in the description so you can have it too. So what I would do is I'll make an empty copy of this and share it with you. What you can do is you can click on file and make a copy and maintain your own copy of it in your own drive. I'll do that. So let me just make a note somewhere that I need to do this. I'm a pretty, give me a minute. Add DSA problem sheet link to today's live stream video. Yeah, I have set the notification. Nice. So again, the idea is basic and we wouldn't be doing wrong. Okay, actually do need to fill this after finishing that. Let me just do it. Hello, it's hello functions and it's CPP. I like to do it this way. So like I make a folder for each one, and inside it I'll name the code in the way I can understand if I return back. So let me write the basic boilerplate code hash include IO stream using namespace std. Thanks for the suggestion. And int main. So here we need to take n as input, c in n, and for int I equal to 1, I less than equal to n, I plus plus, we need to see out this. Oh my god, I made a mistake here. See out. We, and again during programming we need to remember something very well. We need to print exactly what they gave. So I'll just copy this and paste it here. So even if I do a capital S here, that would be wrong. So we need to make sure that we need to print exactly what they ask. Like there will be many issues where like instead of, I'll just show like they would be asking to print yes in capital letters, whereas we do something like this. Y is capital and remaining are small. or they might ask everything is small, but we might give everything capital. So you will be losing the points or whatever, getting wrong answer, mainly if you are doing it in a contest. So yeah, I think this is it. Let me test it. So however confident you are, like anyway, like you are not, I mean, not you, it's me. This is me talking to myself. Anyway, you are not doing a time sensitive hardcore contest. You take the time to validate your test cases. So here I was asked to print this the number of times I was the user gives input. So I'll test it out. I'll take the time. I'll submit it whenever I feel like I'm confident for it. So I just compiled it and I'm running it now. You see, when I gave three, it gave me three times. Let me give eight and count. One, two, three, four, five, six, seven, eight. Yeah. Now let me submit this. I'll just submit this code. Hello functions, choose file. Oh, I forgot it here. Work 100x devs, DSA. Yeah, this is the code. It's running the test. Let's wait for it. Yeah, it's accepted. That's cool. It's pretty easy. Print function factors one. Now I can go ahead and actually update this stating like, yes, I solved it, and do I have to revisit? No, I did it very well. This is also basics. Let me fill the other details later. Let me go through the problem. You are given an integer and write a function that prints all factors of n in increasing order, which means from small to big. A positive integer d is called divisor of factor if n mod d equal to 0. They gave the definition of a factor. The only line contains input is the only line contains n, and n could be from 1 till 10 power 5. So basically we can happily use integer data type here. There is no need of uh, long or anything of that sort. Print all factors of an increaser separated by single spaces. You see, like this is important. We need to print space between one and the next factor. And based on this definition, let's see what factors is, and let's consider this example. So we have 12 here. Um, so we know what a factor is. Like whenever if we are able to divide a number and get a remainder as 0, if we take 1 are 12 and we have a remainder as 0. This is important. Uh, Next, let's take 2. When we have 2 6 are 12. Here also the remainder is 0. So this is also a factor. When we take 3 6. Oh, my bad. 3 4s are 12 0. If we take 4 4 3 is 12 0. If we take 5 5 2 is 10 2, this is not equal to 0, which means 5 is not a factor. 6 is again a factor. 6 to 12. Similarly, if we try 7, 8, 9, 10, 11, they are not factors. Um, so here as let's see, 1, 2, 3, 4, 6, and we know like 12 by 12 is itself a factor, right? So the answer would be 1 space, 2 space, 3 space, 4 space, 5 is not, 6 space, 12. So here again, n is 12, right? We can input, we can run a loop from 1 to 12. We can test it out, and this would be I, right? The loop variable. Mm, that loop variable would be I, right? So we'll just do that, like, yeah. So if let me clear some space here. Okay, so if n mod I double equal to 0, what we'll do? We'll just see out I, and here is the most important part. We'll output a single space after I. If we don't do it, all of them will come combined. I'll show you it in the code and test it out. Yeah, that's what it takes, I think. Let me just code it out. Print factors 1. Let me clear this out. I'll take the boilerplate code from here. I'm very, you see, till here it's the same. I equal to 1 and I don't want this suggestion. If n percent I double equal to 0, see out I. This gave the same suggestion, but here let's test it out. G++ print factors 1.cpp /a .out. Let's give the input of 12 itself. You see what's happening here? There is an endl here, so after printing every factor, it's ending the line and it's going to the new line. But what do we want here? A space. Now let's see, like, what if we don't give an endl here? Command s. Now let me compile it again and run it again. Give 12. You see all of them got combined. We don't want this also. We want a single space after this. So what we do is this. Command s. And so after each factor, we are printing a space. That's exactly what we need. Let me just test it out. Give it 12. Yeah, so this is how it's printing, and this is how we need it. Print all factors of n in increasing order, which means small numbers first and large numbers next. So 1 2 3 4 5 6 until 12, which is increasing order, separated by single spaces. That's exactly what I did, separated by single space. So when you test your output, you need to compare even the spacing and all, so that you need to make sure that everything is exactly how it's asked. That's the most important thing. And you know, like how computers deal with, like, it needs to be exact, else it's just an error or something of that sort, right? It's running the tests. And one more thing, after doing these many tests, you might think like, uh, I might not run into an error, or I checked everything. There is nothing that could break my code, something of that sort. You will be surprised when doing a slightly tougher problems than your level, because uh, in computer science there are more ways to lose than to win. Like, winning is only one thing. Even one semicolon can make you lose stuff in computer science, so, and in programming. So just be sure of what you do. Learn things, take out the time to learn stuff, apply them. Yeah, be confident, but don't be overconfident. And it's fine if there are errors and there is issues, right? Like, even in a live that I did yesterday, I wasn't able to solve a problem. What happened? Nothing happens. I just mark them as revisit and I'll get back to them later. That's all. You must be open to learning. That's all, nothing else. So here it's the same thing, but notice the difference. Um, they're asking it in the decreasing order. So let's get back to the drawing board. Uh, okay, where is the select tool? Yeah, here it is. Yeah. So here earlier you see we have written a for loop like this. Um, we have taken input. I'll not write that for now. I'll just write the for loop. I equal to 1, I less than equal to n, or I'll write it as it is how we write in code. I less than equal to n, I plus plus. If n percent I double equal to 0, again see out I, and that's a space next to it. Okay, here you see, like, taking the 12 as example, we are running the loop from 1 2 3 so on till 12. Hence when we print, we are getting output from 1 2 3 4 6 and 12. Like, this is ascending order. So if we want the opposite of this, um if we want the opposite of this, mm, what do we want? Like, how do we do it? What I say is, like, for the same 12, if we want the opposite, what we'll do is, somehow make the loop run from 12, 11, 10, 9, 8, so on till 1, right? So in this case, like, whenever we test, first we'll test 12 divided by 12, which is the if condition inside it. Or I'll just show all of it. I hope this is visible. Yeah. Or I'll just get this next to, Yeah. Mm, yeah, I think that looks fine. Let me continue. So now we'll test this condition. Um, we'll test the if condition here for this. So this passes, so we'll print it as 12 here, and then we'll test this, which is no, which is no, which is no, which is no, and so on. We'll test whenever we have 6 here, and we test it out. We'll have it as S, and we'll have 6 similarly for 4, for 3, for 2, for 1. So we'll have the output as 12, 6, 4, 3, 2, 1, and if you see, that is the output here. So to do it like this, all we need to do is reverse the loop the way we want. So I'll make the required changes here. So we'll start I with n. One second. Yeah, we'll start I with n. I greater than 1, I minus minus. Does this make sense, guys? Let's see. Consider, let's do a dry run. Let's not do what's inside, but let's check the loop. Consider n equal to 3. I will be equal to 3, whatever it goes inside, um, and it comes back. Wait, um, the condition is I greater than 1, so it's I, as I equal to 3, it's 3 greater than 1, so it goes inside. Then I becomes I minus minus, which is I becomes 2. So it checks 2 greater than 1, it goes inside again. Okay, it has to run 3 times, so that is I greater than or equal to 1. I greater than or equal to 1. Let's code this. It's pretty easy. We'll take the previous one and make a copy of it. So here, what did I say? Like we'll start the loop from n, and we'll make it greater than or equal to 1, and instead of increment, we'll decrement. Now let's test it out. G++. I have compiled it. Let me run it. Run it. Let's test it out. You see, like we got the output exactly like we need in the decreasing order. So the thing we need to notice, um, whenever we want to run a loop from 1 to n, that's when we do something like this. I'll write both of them. Uh, increasing, increasing, decreasing. So it's the same for loop. The thing inside doesn't matter. We are only comparing things which uh, changes. So So we have these things, right? Um, the initialization, the condition checking, and the updation. So this is the most important thing. So I'll just write it in black. So here when we want it increasing, we'll start with the lower value. We'll check if it is less than the value we want to, less than or equal to the value we want to reach. And as we are going from small to big, we'll keep incrementing. Now in the decreasing case, we'll assign initialize it at the bigger value, and as it's decreasing and the finally we want it to reach, and we'll keep checking if it is greater than or equal to 1 or not. And as it's going from a bigger value to smaller value, we are decreasing it. So in both the cases, let's say for some case the value n is 15 or not that big value, so let's take it as 1 4. So here the loop runs, the values of I would be 1 2 3 4, whereas here the values of let's take n equal to 4, the values of I would be 4 3 2 1. So that's the difference between an increasing and decreasing loop, and this is how you do it. I hope this is clear. We solved two problems on this, exactly this, using this um, just now. Let me just go ahead and submit this. It's running the test, so that's cool. It's accepted. That's nice. Oh my bad. We are doing this. Check prime. You are given an integer n. Write a function that checks whether n is a prime number or not. Print prime if n is prime, otherwise print not prime. The only line contains an integer uh, value n ranging from 1 to 10 power 5. Okay, this is it. So right now we just did factors, right? And prime is pretty much linked to the same. So if you know the definition of a prime number is a number which have exactly two factors. So we can take few examples. So let's say we take 3, and again I didn't finish the definition, which exactly have two factors, and the factors are exactly 1 and itself. So let's take the case of 3. If we divide 3 with 1, we get 0. If we try with 2, no, it doesn't work. It's not a factor because we have remainder as 1. Next, if we try with 3, 3 ones are 3 0. So here it's not a factor. 1 and 3 are factors. So if we generalize this, if we have n must have only two factors, and the factors are respectively 1 comma and that's how it usually will be. So we have seen how to get factors just by dividing, and what we can do is just count them right in the same loop. uh, we'll see that, and before going to solve that, we need to make sure one thing: 1 is not prime, not composite. So this is the definition of a prime number. It must have two factors. One fails at having two factors. One only have one as its factor. So I hope you get it. Uh, so I clearly specified this because in our input test case, uh, this is one of the case. So we need to make sure that if the input is 1, we need to write it as not prime. So yeah, let's continue. So let's revisit the code which we have written for factors. So for I is equal to 1, I less than equal to n, I plus plus, um, if n mod I is equal to 0, C out I, right? This is the code we have written to print the factors. So now the task is not to print it, but we need to check if it is prime. But to check something, if something is prime, we need to know how many factors it has. So what we can do is here, oh, I write it very badly. So I'll remove this. So here, let me take a variable at the top. Here I'll create count variable and initialize it to 0. If this condition satisfies, I'll I'll just increment the counter cnt plus plus, and instead of finishing it here, what I'll do is if count double equal to 2, I'll print it as prime. So okay, the for loop is done. This is after the for loop, and also one main thing, as I want to access count outside this, um, I need to make it available there. Oh my God, how do I do it? I'll just write it again. Int count equal to 0. Let me make it a bit clear. Mm, okay. So you see, whatever is here is the main thing. So that's the main for loop. Um, After doing that, we'll continue to do this. If the count is double equal to 2, it just means that is prime, right? So we'll see out prime, else see out not prime. We can take an example of n and dry run this. So let's take n as let's take this example itself. NS4. Here, initially we have the variables count, I, that's it. So initially the count is 0 and I is 1. It just the condition is I less than or equal to n, 1 less than or equal to 4. This is true, so it goes inside. It checks 4 mod 1, that is equal to 0, so the condition is verified, so count is incremented, which makes the count as 1. Now let's take 2. 2 less than or equal to 4, which is right, it goes inside the loop. Now it checks the modulus. Yeah, 4 mod 2 is also equal to 0, so count is incremented, so that becomes 2. Now the I value is 3, 3 less than or equal to 4. This is correct, it goes inside the loop, but here the modulus operator is 1, which doesn't satisfy the if condition, so the count doesn't increment, but will go out of the loop again. Here we have count as 2 and I value as 4. 4 less than or equal to 4, the condition is true, it goes inside loop, it tests 4 mod 4 equal to 0, which is right, so the count is incremented again. um, so the count is incremented again. So if we come here, the count is 3. uh, so now the I value becomes 5, 5 less than or equal to 4. This is where the for loop breaks. Now let's go back. I'll write the final count value here for reference. So the final count value is 3. Now we need to check this case. So if count double equal to 3, is 3 double equal to 2? No, right? So the if condition is failed, so else will work. What is there in else? Else says just print not prime. So not prime will be printed. That's exactly what we have here in the test case. Now, so that as we are clear on this, let's um, code it out. I'll enter this in sheet. Oh, I forgot to add prime factor 1, prime factor 2. Let me quickly do that first. That's important for me. Oh, why did it become slow? My bad, my bad, my bad. This is also basics. I have solved both of them. Yeah. Now let me write this fourth one. Check prime. Okay, this is enough for now. Check prime is the check prime dot cpp. I'll take the earlier factors code as it's pretty much similar. All we need to do is initialize another count variable and just put it, initialize it as 0. Instead of printing anything, you just increment the counter and it's giving me the right suggestion. So we verify um, it in a way that if the count is 2, it's saying yes, but we exactly need it to print it as prime. So what we make this a habit, like I don't know, like it's working pretty fine for me, that copy and paste the results exactly as in the question instead of writing or typing it out. I don't know like what exactly does people in competitive programming follow, but at my level, in my rating, I'm just talking about people who are at my level. By seeing the problems I'm doing, you can understand my level, right? So if you are someone of this level, I think this will help you big time. Try to do that instead of writing. We always make mistakes when writing things. I'll give the same input 17, I got prime, and if I give 4, it gives not prime. So I'm pretty confident with this. I'll submit and see. Yeah, so for me, copying and pasting the exact output that they need is working out well in my favor. You can try and decide what works for you. But I seriously think like uh, we make mistakes when we type out things. It's accepted. That's cool. Uh, so next one is factorial. I have written multiple ways to do factorial earlier. So one is just taking a for loop. Now let's make a factorial function. Oh my god, I have been doing it wrong. Let's see what was asked. Write a function that takes n as parameter. Oh my god. Guys, every question, like though it got the output, the thing I need to do is wrong. I am supposed to write functions. Hello function, see out hello function. So whatever is here, I need to put it here and then say int n. Here we just call that function hello function of n. Yeah, done. We get the same output, but it's completely different. Hello function dot c plus plus. Let's. I didn't put a semicolon somewhere. Line 8. There is a semicolon here, right? Or I'll use it as void. Non-void function doesn't return any value. I should have it as void because I'm not returning anything. G++. I mean, I have compiled. Let me run this. I'll give it 3, 8. Yeah, I'm supposed to do this. The technicality is like I was asked to write a function there. That's what I'm thinking. Like I'm just writing for loops as if I did the last assignment. But where is the differentiation? It just hit me now. They want me to write functions, dude. So again, this is void print factors ascending. We take an integer n, we just copy paste this code, Command V. Wait, what's happening? Okay, I think this is good to go. We'll just call this print ascending of n. So sorry that I just missed that. Print factors 1 dot cpp dot slash a dot dot. Will print factors to it printed in ascending order, or I think it's easier for me to do this here. Print. I'll just copy and paste. Yeah, I'll do this thing of, oh, it's small. And so you see, like, I just did the change, and here I think this should work now. G++. 12 6 4 3 2 1. Yeah, that's right. Check prime. Now let's read the prime question once again. This is done. This is done. Write a function that checks whether n is prime number. Print prime if n is prime, otherwise print not prime. So we need a function that checks n is prime. So let me write a bool function for this. That is the learning here. So we want is prime to be a function which returns boolean. So here I can write return true, and below return false. I no longer need this. So you see what we are doing, instead of saying if it is prime or not here itself, we are returning a boolean. So is prime is a function which takes input of an integer and returns a boolean which is either true or false, stating if it is a prime number or not. So we need to write another condition here. So if is prime of n, uh, here is what we will exactly copy it out. Command C. We don't want all of this. So prime, this is one thing. This is not prime. Yeah, this is exactly how I want it to be. Let me compile it and test it out again. I'm not going to submit this again. And sorry, it's purely my bad, though it worked. That's not what was asked. But now I did what was asked. So hope that's fine. Let's go with factorial. So here we write factorial by taking n as parameter and we written n factorial. And you see, um, this is one thing here. The range is from 0 to 20. And we see that by definition 0 factorial is 1 and the constraint n less than 20 ensures the answer fits in 64-bit integer. That's the important thing. So let's go ahead and code this. This is just classic uh, for loop running from 1 to n itself. Factorial dot cpp will write uh, factorial. So it's giving the right suggestion, but see, we take a variable and initialize it to 1, and every time what we do is we multiply uh, fact with this number, so we get the product of the number from start to finish, right? Like if we take 3, the loop runs from 1, 2 and 3, and each time we multiply that to our fact variable, and finally we need to this is an we need to make it an integer, and we need to return the fact variable. uh, let's call this, and calling it is not enough, like we need to print it. Yeah, so I hope this is understandable. um, you see, we started with a variable to maintain the factorial. We are running the same for loop starting from 1 to n, as we know, uh, and we are multiplying uh, the current value to the factorial every time, and finally returning the fact. We'll get it here, and that will be printed. One thing you might ask, like, what about 0? So the thing is, when we get 0 in the question itself, we were told that by definition 0 factorial is 1, right? So let's try run this. N is 0. Here we are initializing fact as 1, and I is 1, and the condition is 1 less than or equal to 0. So the for loop doesn't even run. And as we are returning fact, as we have defined fact as 1, in the case of n is 0, we'll get fact as 1 itself, and get it back, and that will be printed. Now let's try run this with these values 120 and 5040. G plus plus factorial dot slash a dot out 5, that's fine, and 7. And note that I have given an handle here. I don't think it should matter. Let's try it out. If we don't get uh, Any error, then let's leave, else we'll just remove it. So when it asks to print a single value, it usually doesn't matter if you append a line or not to it. Um, anyway, but it totally depends how the output format is defined. I'm wrong answer on test 21. What's 20 factorial? Wait, 20 factorial is this? Yeah, there is no way an int can hold this, right? Int range is only till 10 power 9. Let me make it long. And n can be int here. We are just dealing with long for the fact variable. Let's try out and give, or let's try out before how it is. Let's give 20 here. See, it's giving a minus value. It's definitely wrong. Well, we need to, oh my god. I made a mistake. I'll just not save it and open it again. Yeah, this is fine. I'll make it long. That would make it fine. So you see, like I'm returning fact. So as I made this variable long, I need to change the return data type of this function also. I hope that's clear. And now let's compile it again and test it out with this big value of 20. You see, we got the right value. I think this should run well now. Let's see. Factorial. Meanwhile, let me do this. It's basic. Guys, I'll come back on live again. The thing is, I do have a class now. Today is AI class in the 100x bootcamp. Uh, I'll leave it for now. Let me check my submissions. Yeah, it's accepted. So we are here. I'll continue exactly from here. We do have 4 problems to deal with. So that's it. Bye for now. See you again.